So let's focus a little bit on the flushing of South Australian Gulf. I want to introduce you to the concept of water age. It's a theoretical concept. Okay, it's a method used to determine something we call flushing time. How long does it take for a region inside an estuary to be replaced by seawater from outside the estuary? And we use the concept of water age. Okay, so what you do in order to understand that is you imagine that your domain is filled with many water parcels, each having an age property. So you can measure the age. Imagine that you can measure the age property. So you have all water parcels, and this is a top view. Imagine that this is Spencer Gulf, and you have all your water parcels in here, and the initial age is 0. Okay? And outside your estuary, the water parcels always have an age of 0. So anything that enters your domain starts aging. Okay? And you also start your simulation, and everything starts to age inside your estuary. Okay, so then you ask the question, so if you now run your simulation or let the system adjust to an equilibrium, the question is, what is the steady state? What is the equilibrium average age of water parcels that you find inside your estuary? So before I show you the results, actually, we just further explore the concept of water age. Have a look on the next one. So let's have a look on the left sketch first. So you see a top view of an estuary, of a negative estuary, and you get actually water coming in on one side of the estuary, and this is what happens in Spencer Gulf. Okay, so you get new water coming in, seawater coming in on the left side, on the western side, and you have an outflow on the eastern side. Okay? So now you can have a situation that actually this inflow does not influence the entire length of your estuary, only the lower reaches. Okay, so you can have a situation where you have one part of your estuary. You can classify this as a retention zone, actually always contains relatively old water. Okay, so the flushing ability of the inflow is limited to a certain fraction of your Gulf. Okay, and you will see that this actually happens in Spencer Gulf. So now, why do you get a steady state at the end or in equilibrium? Is because you have a situation after some time where the entrainment of younger water offsets the aging. You're only interested in the average age, and you always bring in younger water into that system, and it offsets the aging. Plus, you also have an export of older water with the outflow. It sounds all weird, but these concepts work beautifully in reality. We have a look at how does the water age distribution look like in Spencer Gulf if you apply this concept to a computer-based model. Okay, you have a computer-based model that is able to predict the tides and the average density-driven flows in a region. Okay, let's have a look at that.